Hello, my name is William from Group 22 of Software Evolution and Maintenance. This is assignment 3, and I'm doing a self-reflection video on refactoring. That is based off of the requirements needed for this assignment. R1 and R2 for phase 1, R3 for phase 2, R4 for phase 3, R5 for phase 4, R6 for phase 5, and R7 for phase 6. So let's get started. We show the code before we do any sort of refactoring. We can see that this code is very messy. All the codes are kind of bunched up together. We have variables with no descriptive names. So we need to fix all of that. So one of the first thing that we need to do for R1 is fixing the variable names and giving them more descriptive names. And the reason for that is actually very, very simple. For starters, they have a comment that to explain the variable or what the variable is, which is fine and all, but let's say you have a very long function, or maybe just a long line, a long file of code. Let's say around 500 to 600 lines of code. Well, you may be using that variable somewhere within like 500 lines, and then you have to all of a sudden you have to scroll all the way up to check the comment to know what the variable is storing. So that could be detrimental. That could be wasting a lot of time, and you could lose where your cursor was at. Because you're like 400, 500 lines of code in, and you're scrolling all the way up. And that's not even the worst part. What if the variable was around like line 200 and you just don't remember where it was at? All of a sudden, you don't know what the variable actually stores because the name doesn't make sense. It's not descriptive enough. So you have to rely on a comment to know what the variable is storing. Now, having a comment is technically a good practice, but I personally think that comments should not be used to describe what something is doing, but more so why a piece of code is there. For example, it should not be saying what that variable stores or what this piece of code does, because the code should be descriptive enough on its own. And instead, it should be using comments to explain why a piece of code is there. It could be, for example, a critical piece of code that may not make sense, but is something that fixes a bug. I've seen this happen in many places, especially code from Microsoft and Steam from Valve. They have their source code, have some comments there, just say, don't remove this code because this helps do something. It's far more intuitive and better just say why a piece of code is there than say what the code does. I mean, having a comment of saying what a code does is also good if the code is complex, if it's a complex algorithm that it has to be explaining. So, but for explaining something as simple as a variable, you could just do it with the name of the variable itself, so it doesn't really make too much sense to actually describe it there instead of just using a descriptive variable. The next thing for phase 1, also, which is the requirement 2 for refactoring, is to, I believe, separating the splitting variables, because we have down here boolean sorted false, and then string temp equal null, and then below somewhere here during the next bubble sort, it's reusing that variable. This is bad practice. Well, because you could potentially forget to reset this for the next bubble sort. In this case, I don't think it's too big of a deal. Actually, no, it will cause a problem because sort would still be true. Because if you forget to ever set sorted to false again before you just do the next bubble sort, well, the next bubble sort is not going to work as you would expect it to. So basically, this is a bad practice. So you should have specific variable for specific algorithms. But on top of that, it could potentially also help with micro optimizations. For example, this bubble sort here is called once, and it uses the sorted and temp variable. but it doesn't get used again until here. So potentially, if we call a new variable, although this is not really a big file, so it doesn't really help that much, but let's say this a giant file with like hundreds of lines of code, and you use the variable at like line 1, and then you reuse the variable at like line 600, all of a sudden that the line 600 code is using it again, which means that the garbage collector in Java, in the Java compiler, Java runtime, won't actually clear up that space that's not being used by that variable at the moment. So instead of just having that variable sit there unused up until like line 600, which may take a while to even get to, depending on what your algorithm or program is doing, you could potentially just you stop using that variable, declare a new variable for what you need to do again, like 600 lines later. This way, it'll garbage collect the first variable that is not used for like the next 600 lines, and then you free up some space in memory up until you redeclare a new variable for it to be used. Again, this is just some very micro optimization, but if it ever does get to a point where it's it's a variable that's storing a very big value for whatever reason, it could potentially save quite a bit of memory. So yeah, so it could also help with micro optimizations. So phase 1, we have split the variables to movie sorted and movie temp, and also member sorted and member temp. So now we know what each variable is storing as well. So we know what this sorted variable is actually storing for what exactly, and also telling you what the temp variable is storing. It's not just temp anymore. You actually know what it's storing temporarily. So this also could be useful if you ever need to use this temporary variable again later down. Well, you know that exactly what this variable is storing. This is on top of my head right now. I can think of things like recursion, say traversing a binary tree, or anything, or maybe a linked list. Actually, just going through a binary tree itself, you would be storing the current node temporarily in a variable. All of a sudden, it makes a lot more sense to name it something like current node or next node or something like that. So you know what that temporary variable actually stores, and not just temp. But yeah, so we'll split in the variables here. Also, we renamed the variables to having full proper names. So movie titles, new movie title, down here as well, movie store members, and a new member name. Then for phase 2, I believe is extracting the two methods. So because right now the current code violates the dry principle, which is do not repeat yourself. We're currently repeating ourselves twice. So we're repeating the bubble sort once, and we're also repeating the linear search once here as well. So we're repeating ourselves twice. So essentially, we're writing the exact same algorithm for bubble sort and the exact same algorithm for linear search twice. So that's not really good, because now if there's a bug in one linear search for whatever reason, we'll also have to do another linear search. That means that if we fix one linear search, we'll have to fix the other one as well, which causes a bit of problems for maintenance. But before I move on, this linear search is also not optimal. It's just saying found equals to true, and not breaking out of the loop, which means that after it finds, it still goes to the loop instead of exiting the loop early. So that's also not optimal either. So in phase 2, we extract the two methods out. So now we have a bubble sort method and we have a linear search method. And the linear search method is now just returning true if it gets found immediately. So it doesn't go through the entire array if it's found early. And then it returns false if it went through the entire loop. That means nothing has been found, so we just return false. So for the bubble sort, we go back to saying sorted and temp, because at this point because we're using a method, this is technically a generic method, not really a generic method, but like a method that's being used by any array list that is a type of string that stores strings. So it could be any string, or so this is just going to be called temp, and this is sorted. So the value here doesn't matter at the end of the day. And also we're not returning anything because this is passing the array as reference. So anything that happens here is just going to update the original array. So it's going to mutate the original array. So we don't have to return anything. So then we just need to call the methods here and here. So now we don't have to repeat ourselves twice. So we can just call the method directly here for bubble sort and call the method for linear search here directly. And yeah, that is phase 2 done. So for phase 3, it is talking about replacing the array with an object. So okay, so for phase 3, we create 2 extra classes. So we create a class for movie and we create a class for member. So this way we have different objects for the different things we're saving, because members can in the future not just be their name. They could have different attributes. They could have different methods that they can use. Same thing for movies. It's not just always going to be a movie title. Maybe it'll have a rating later on. And so having a class, being an object, we can easily extend that and add more things to the movie class. And not just store it as string. And that also causes another problem now. Well, because the bubble sort, we now need to duplicate the bubble sort method, because we need to store we need one method to do for a movie, and we need another method to do for a member. And same thing for the linear search, and another thing for the linear search. So once again, we are breaking the do not repeat yourself dry principle. So this is not really a good practice either. But for the sake of following R4 for phase 3, it's just creating 2 versions of the search and the sort methods. So that is phase 3 done here. So in phase 4, we fixed that. We fixed the dry principles that we are violating by creating a generic method. So we can just pass pass t here, a generic. So we just make the bubble sort and linear search a generic method. This way, we can just pass in any array list, and then we can still be able to use these methods. So now we no longer have 2 bubble sorts and 2 linear searches anymore. So that's a good thing. So the difference that we have to do is we need to pass in a comparator, because the array can be anything. So what we're comparing could be also anything. So the method needs to know what it needs to compare. So that's why we're passing in a comparator object. The comparator is just essentially our M1, so movie 1's title and movie 2's title. So we're just comparing those two. So and then just do the bubble sort like normal. The same thing with linear search. We need a getter for the linear search. So we pass in the list the item to search just like before. But now we also need to pass in a getter, because, for example, for movie we have get title, and then we have, for member, we have get name. So those are 2 different getters. We can't just use get title because, well, it won't work if it's for a member. So we need to pass in the getter. So the getter is simply just passing it like this. So we're just saying for movie, it's movie get title, and member, it's member get name. And then it'll do what it needs to do, and it'll apply that getter and do the search linearly. So that is phase 4. And then phase 5 is parameterize sort and search methods. So you have one method. Oh, sorry, that's what we just talked about. So refactoring 6 now. is substitute algorithms for sorting and searching with better ones in regards to performance. So bubble sort has a time complexity of OMN squared, because if we take a look at it, it does a nested loop. So worst case scenario, if it's exactly sorted in descending order, it's gonna take exactly O(n) squared time to sort everything, right? So because of the nested loop. Now we also could optimize this a little bit better. Actually, no, it's already optimized. So yeah, this would just break early if it's no longer swapped. But it's still a time complexity of OMN squared because of the double nested loop here. So we can optimize that by using some form of better sorting algorithm like a merge sort. So that would bring our time complexity down to O(n) log n. So it'll break everything down, and then it's gonna go in halves. It's gonna break it in halves. So that's how we get log n, and then we're gonna be merging them, and this merging takes O of n time. So that's why it takes O of n log n time. So we can make use of a merge sort instead to optimize the performance of the sorting algorithm. And the reason why I personally opted for merge sort is because it is stable compared to something like quicksort. Quicksort has a best time complexity of O of n, but it has a worst case time complexity of O of n squared, which we don't want to get to, because if we choose the wrong pivot point. So that's why I'm not using quicksort, and I decided to just simply opt for a merge sort. As for linear search, we're replacing it with a simple binary search, so it goes from O of n to just and optimize the binary search with the binary search so that the time complexity becomes O of log n. Because it just goes in halves. So we have the merge sort here. So we have the merge sort, and then we have the merge, the method that helps merge everything together, and then we have the binary search method down here. So that is the optimization done here. And then finally in phase 6, we can see that there's actually some errors here with phase 5 from phase 1, from before refactoring all the way to phase 5, and that's because of this input scanner here. In phase 6, I fixed a lot of other issues that there were, besides R7, which was basically telling us to create a utility class for the sorting and searching methods. So quickly, we just create a utils class, and then we just make all the methods static, so that we can just access them easily by using utils dot, utils dot merge sort, utils dot merge sort here, utils dot binary search, and utils dot binary search here. So it's very simple. It's just having a class there. So it makes more sense as well, so that everything is encapsulated into one class for utilities. And so yeah, that is pretty much it. But some other things that I fixed were replace the scanner input declaration to use a try with resource syntax. This way, once this is no longer used, so like after line 121, it'll just automatically close the input, so it won't leak resource. Compared to here, it will, if it never gets closed, so there's possibility of resource leaking, so it'll cause memory leaks and eventually slow down your computer. So just by, did I change something? Oh, there we go. Okay, so we just want to go ahead and use a try with. I could simply just use the input.close method, but I personally prefer this. That way I don't have to make an extra method call. It'll just automatically do it for me whenever it's no longer needed. So yeah, that's the try with resource syntax. I also added a few extra like empty print lines here and there to really quickly space out the methods, or not the methods, but the prompts and the inputs and the outputs, so it's easier to read in the console. Some other little things I did was also remove the string here. If we go to the before refactoring here, there's a string array list here. It's this part is completely irrelevant, so we can just remove that because the code already knows it's a type of an array. It's already it already knows that it's an array list of string. It's not necessary to put that there again, so you can just leave that empty. Without putting it empty, my IDE just screams at me. Things like also removing the null, because by default it's already null. So it's just remove those as well. Certain few things I also changed was change stuff to print line. So it's easier to read. Sometimes it's just print, everything is just clumped together. Like you can't tell where your input starts and where the output ends. So having print line at least puts them onto a new line. I didn't want to edit the original string, so like by adding a colon or anything like that. So I just decided to just add a new line. It'll make things a little bit easier. So yeah, so added print line everywhere. Same thing, instead of using simply .next, I replaced them with next line. The next line is just so that if, let's say, a movie title is 2 words long, it doesn't count it as 2 movies, it counts it as 1 movie. So yeah, that's next line. And then I'm trimming it because so that the start and end, if there's ever spaces left by the users by accident, it just removes those spaces at the end. So it removes the trailing and leading spaces in the string. So that way it'll help a lot as well. So for example, when you're searching for something, it doesn't include that space as well. Yeah, I think that's everything I changed. What else did I change? Right, I also did change the Boolean comparison. So for example, if member found, instead of, I believe down here, it's equals to true. Yeah. So for better readability, this is so pointless. So I just removed the equal true and remove the else if, because if it's true here, this is obviously going to be false. So I just removed, went ahead and removed that to be false. And I also spaced out the code a little bit, so it's a little bit easier to read. So they are clumped by blocks that make sense together. For example, this print line and this print line make sense together, and this also makes sense together because this is the same output block. This all makes sense together because this is part of input, and then immediately this is search. I could add a space here, but it feels a bit lonely on its own line, so I just decided to clump them together. But yeah, that's pretty much it. I think that's everything. Very quickly, I forgot to show, before the video ends, I forgot to really quickly run the code for phase 6 to show that every output is still the same. So, enter movie title, say, Spider-Man, The Dark Knight, and then let's say a Minecraft movie. So we can enter them like that. So now everything is better. It's not all clumped together. Before it would be, if it's the second input here, you would type starting here, which does not look pretty. So you couldn't really tell whether or not where this sentence ends and where your input starts. So having them on your line is makes things a little bit easier for the user, just enhancing user experience. And we can just type end here. And we can also see that it separates this, so you can immediately tell that this is before sorting and this is before, this is after sorting. So we can see that after sorting, it's still sorted. So everything still works as before, and the outputs are the same as before, it's just with extra empty spaces so that it's easier to read. So let's say William, let's say and we can see, I'm going to just type end here, and then we can see members before sorting, and then members after sorting. Everything is still working like you would expect it to, using a binary search instead of a linear, using a merge sort instead of a bubble sort. So next is the enter a movie title to search for. So let's say we add a space at the start. We add multiple spaces at the start. So we say a Minecraft movie, and let's say add multiple spaces. Hit enter. We can still see that the movie title is found because I decided to trim the input. So the spaces gets removed, so it can still be found in the bubble sort. So because, well, the spaces are removed. So we can see the, sorry, did I say bubble sort? I mean binary search. Yeah, so the binary search is still working. So the searching algorithm is still working from linear search to binary search. Similarly here, we can search for my name here. We can also add some spaces before and after. And I hit enter, we can still see that the memory is still found despite all the spaces, because we're trimming the input. But other than that, all the outputs are exactly the same as in before refactoring. Nothing has changed. None of the outputs are changed except for adding extra lines here for better readability. So yeah, now thank you very much for watching.